Hi everybody. In this video, we're going to look at connected rates of change, and this is all about applying the chain rule of differentiation. We'll begin with example 1. We're told that a is 4y cubed, and that the rate of change of y against time, dy by dt, is equal to 5. We need to find dA by dt. We could also say this is the rate of change of a over time. So if we use the chain rule, we want to find dA by dt. And what we have is dy by dt. So using the chain rule, if we multiply this by dA over dy, then you can see that these dy's will cancel. And what we're left with is dA over dt. And this is what we want to find. We've been given that dy by dt is 5. So dA by dt will be 5 multiplied by dA by dy. So we need to find this. And we can find dA by dy by differentiating this with respect to y. So if a is 4y cubed, then dA by dy will be 12y squared. So we can substitute this back into here. We get 12y squared. So dA by dt will be the 5 times the 12y squared. And when y equals 2, dA by dt, we'll substitute the 2 in place of y. 2 squared is 4, times that by 60, so we'll get 240. Okay? So the way we go about problems like this is we begin with a chain rule. What do we need to cancel to be left with the dA by dt? So if we look at example 2, we're told that the surface area A of a sphere is related to its radius by this formula. We need to find dA by dr. So if A is 4 pi r squared, then we need to differentiate this with respect to the radius. So dA by dr will bring this 2 down and we get 8 pi r. Then we're told that given the rate of change of a radius, so this means dr by dt. You can tell this because you've got a length and a time. So given that dr by dt is 2, find dA by dt. So this is the rate of change of the area. So using the chain rule, dA by dt, we have dr by dt. So what do you think we need to multiply this by to get dA by dt? Well, we need a dA on our numerator to match with this one. And then we need to cancel out this dr. So we need to find dA by dr. And we have that here. So the rate of change of area over time will be the dr by dt, which we're told is 2, multiplied by dA by dr, the 8 pi r. So dA by dt will be 16 pi r. Okay? Let's try another question. We're told that when water is pumped into a tank, it takes the shape of a cuboid with a square base of side x meters and a height of 3x meters. The volume of water in the tank increases at a constant rate of 8 meters cubed per second. So this is dV by dt, the rate of change of volume over time, and this is 8. Find the rate of increase in meters per second of x. So this is dx by dt when x is 2 meters. So we need to find dx by dt and then substitute into that x equals 2, and this will give us a rate of increase. So dx by dt, and we have dv by dt. So what do you think we need to multiply dv by dt by to get this? So if we multiply it by dx over dv, then you can see that the two dv's will cancel. So we need to find dx by dv. And we can find this from the question. If v is volume and x is the length, and we're looking at the shape of a cuboid, well, this will be the area of a base, x squared, multiplied by the height. So v will be 3x cubed. Now we can work out dv by dx by differentiating this with respect to x, and we get 9x squared. But what we want is dx by dv. So we can reciprocate this and we get 1 over 9x squared. And now we can substitute this into here. So dx by dt will be dv by dt, which we know is 8, multiplied by 1 over 9x squared. So 8 over 9x squared. And we're told here that x equals 2. So we'll substitute 2 into this. So dx by dt will be 8 over 9 lots of 2 squared. So we get 8 over 36. We can simplify this, we'll divide both by 4, and we get 2/9 meters per second. Okay, so this is the rate of change of x over time, when x is 2 meters. Let's try one more question. So do you want to give question 4 a go yourself? You can read through the question and come back when you're ready. Okay, so welcome back if you had a go. So we're told that the surface area of a sphere with radius r is increasing at 50 pi centimeters squared per second. So this is dA, A for area, over t. So this is dA, the change in area over time. And we're told this is 50 pi. And we want the exact volume when the rate of increase of r is 5 over 12. So we want to work out the volume when dr by dt is 5 over 12. And we know the volume of a sphere is 4 over 3 pi r cubed. So we'll set up an equation involving dr by dt to find the radius, and then we'll substitute that radius into here to find the volume. So dr by dt, using what we have here, dA by dt, we need to multiply this by dr over dA. These dA's will cancel, and we've got dr by dt. So we need to find dr by dA. And we know the area of a sphere is 4 pi r squared. So if we differentiate this with respect to r, then we'll get 8 pi r. So dr by dA will be the reciprocal of this, 1 over 8 pi r. So we've got dA by dt, we'll substitute that into here, and we've got dr by dA, which we'll substitute into here. And we know that this is 5 over 12. So 5/12 will equal 50 pi multiplied by 1 over 8 pi r, or we can write that as a division. We can cancel out the pi's, then we'll move the 8r over to the left hand side, we get 40r. We'll move the 12 over to the right hand side and we get 600. We can divide both by 10, so r will equal 15. Now we can substitute this radius into the volume of the sphere. So a volume will be 4/3 of pi times the 15 cubed. When you work this out, we get 4,500 pi centimeters cubed. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.